This is going to be a follow-up video, long anticipated, part 2 of how to tune an E36. We're going to be going over how to log, how to compare tune files. Let's see what else I have here. Fuels, spark advance. We're going to get into how to do launch control, which is kind of cool. And of course, Burble settings. A lot of you requested that. And then emissions devices, and then a couple other things. I did want to follow up with some of you in regards to some of the comments, some of the common questions I had. As far as ODB1 cars, they are tunable. They are not tunable in the way that I had showed in the first video. You're going to have to buy what's called an EEPROM reader and EEPROM chips, the programmable ones. You can actually get those on eBay, both the reader and writer, and probably like 20-30 EEPROM chips for like $10. So you actually need a removable chip that goes in the DME, and then that reads it. You cannot directly read and write to those. You have to actually install a different chip each time you want to write a tune. There were some problems with the actual flash utility. I did provide an updated link in that video through Mega. You should be able to download that now, no problem. Other thing is what version of Windows to use. I think Windows 8 and 10 work fine. Probably Windows 7 too. It's nothing too complicated. ROM Raider does require that you have Java installed, so just make sure you have that. And then again, just make sure use the open MS41 wiki page that I had provided in the first video. That's where you're going to get your definition files for the MS41 for it to read in the tuning application, and then any common sort of like questions you might have is going to be on that website as well. So that's a good resource. So let's get into it. I'm going to start off with one of the most important aspects, and that's logging. So getting good data from your car while you're trying to do the tune is crucial. I came up with a pretty good list of parameters to turn on in log, and some different situations where you'd want to log. So let's go over those. So your conditions where you want to log, usually cold start and idle is pretty good, especially if you're making any modifications in airflow to the engine. So let's say intake manifold, intakes, cams, all those are going to change your fueling at idle and startup. Your cold start, that's where your warm-up enrichment will come into play. I'll go over that in a little bit as well. So the other part is doing a solid third gear pull. You want to log where you have 1-to-1 gear ratio, and do a pull from probably like 2000 RPM all the way up to red line to get some good data there. You want to watch for knock, anything weird going on during that pull, and of course doing that in a safe area is important too. The other thing is trying to get a high load scenario or uphill. There are load cells in the maps where you want to try to hit those. Any sort of steep hills or even brake boosting will get you in those load cells to be able to tune those. A lot of tuners will leave those out, and all of a sudden you're going to go up a huge hill and then run into some either fueling issues or timing issues. I've seen that happen quite a bit. So some parameters here to go over and turn on while you're logging. And there's going to be a huge list as you go through stuff. This is just a shortened condensed list, what I usually use. So starting off here, airflow, this is going to be from your mass airflow sensor. If you are running speed density, that would be from like a 3-bar GM map sensor or something like that. But stock, you're going to be going off your map. The other thing is going to be intake air temperature and coolant temperature. These are going to come into play because as your motor gets warmer, and especially in those really hot situations, it's going to pull timing. So you want to be able to know the full picture of what's going on, and you commanded, let's say, 20 degrees of timing and you're only getting 10. Why is that happening? Because your air temperatures are coming into effect. And then most importantly, knock count. E36s do have 2 of these off the side of the motor on the intake side. This is very important to log. If you run too much timing or have really bad fueling, let's say you run, crappy 91 gas like we have here in Arizona, you're going to run into some knock issues if you run too much timing there. And even, switching to ethanol, you could still run into knock if you run super aggressive timing there. So keep an eye out for that. Fuel trims. You have long and short-term fuel trims. And this is going to be a percentage of how much fuel your motor's pulling in relation to what the feedback is getting from the narrowband sensor, O2 sensor. So if it's trying to add like 10% fuel all the time in some areas, you're going to want to make that change permanent in your actual fuel table. If it's constantly trying to correct something, and it will only correct up to a certain point too. So if it's super off, you're going to have to get that dialed in through your actual tables, your set tables. Throttle position sensor and RPM are extremely important because that's what's calculated in your load. And load is the fundamental basis for your fueling and timing maps. You'll see in the tables there's going to be RPM versus load, and this is where it's the ECU calculates the load from. I believe there also is a calculated load parameter that you can log that does this math for you, and that's a lot easier to go off of when you're trying to match stuff up and trying to figure out where to make the changes. Vanos engagement, you're just trying to see where Vanos might have engaged. If you're trying to deal with some problems, turning that off completely and then starting to ramp that back in might be useful. So that's where that would come into play. Logging a narrow and wideband sensor. Stock, you're going to have a narrowband O2 sensor, obviously, and then if you add a wideband, there is an area where you can also log that as an input. I'll show you how to get to that in a minute. Timing advance, you definitely want to log that. And injector duty in milliseconds. This is how long your injector is open for in spraying during an engine cycle. So obviously that's pretty important because you'll get to a certain point where you're going to max out the injectors and you want to kind of keep an eye on that. So that's pretty much it for the logging parameters. Using the ODB2 cable that I provided in the first video, building off of that, you're going to be using, when you install the ROM Raider suite, it comes with this logger. I think they have 2 different versions. One can run off like a tablet. There's a full screen view. This is the normal one. But essentially you enter which COM port your ODB2 reader is connected to on your PC. I believe I went over that in the first video. And then your parameter list, I'm not actually connected to a car right now, but once your definitions are loaded in and your car is connected, you're going to see in the parameter list here a list of parameters similar to what I showed before, and those are the ones you're going to want to select. There's going to be checkboxes here and which ones to log. There is a list of external sensors, so if you do have a wideband, I believe you can log, I think, ethanol content sensors, flex fuel. You can have more advanced NOx sensors to have here. So if you want to really get crazy with this, you can log all kinds of additional sensors here. So when you're ready to actually start the logging, you just click this start file log and it will save that. And this is actually where you're gonna add the name of the log file. So let's call it, third gear pull or idle or something like that. So you know what that log file is related to. And here's the start and stop. So now I have the main ROM Reader application opened. The first thing I wanted to show you is how to compare your bin files. That's going to be extremely important when you're trying to trace any changes or any variances you made from one tune to another, or your tune versus the stock bin, to see if anything goes wrong, you can trace that back. It's pretty powerful. So what you're going to do is the two bins that you want to compare, you're going to open both of those up. So right now I have an original MS41.2 bin. So I'm going to open that one up. And then let's say this tuned one that I have, open that one up too. And then we're going to go to edit and then compare images. And then you can see here, any bin that I have open is selectable. So I'm comparing the tuned one to my original, and then just hit compare. So anything in green is going to be unchanged. Anything in red is going to be a changed parameter. So let's say secondary air pump. You can see that in the original versus the modified, the original has this secondary air pump enabled and this one is disabled. So that's pretty easy to track that. If you get into fuel tables, so let's do compare, and let's go down to fuel injection. What this is actually showing is the variances between the two. So between the original and the tuned one, your, let's see, unchanged here in the fueling, reduced a little bit of fuel here. So you can kind of trace that back to see, what's actually going on. And I believe you can, if you go to this compare, you can turn off the changes. So if you want to see the original side by side, you can do that as well. Next, we're going to be going over fueling. So there's a couple tables here that have to do with fueling. So you have your base fuel injection table here. And again, this going back here to load, this is your load cell that you would be logging to figure out where in the map you are running lean or rich based on your fuel trims. And then, of course, engine RPM is on this side. And then this is dealing in injector pulse width milliseconds. So, for example, in this cell, your injector is open 11.24 milliseconds. And as you get into changing fuel injectors, or you're making any changes to how much air is coming into the motor, whether you're forced injection or making changes to cams or intakes, you're going to have to change certain areas in this map based on the different characteristics of how much air you're flowing into the motor. You definitely want to make smaller changes here, and the one thing that's kind of interesting is if you are going from, let's say, like a M3 pink top to 1000cc injector, you just have to do a little bit of math of the percentage difference that let's say you're flowing 1000cc instead of 250 with the pink tops. You would just do a little bit of math to see the percent change, and then just change this table overall to get a base with a full fuel injector change. So here are your fuel injection cranking tables. So again, this is pulse width, and this is based on coolant temperature. So if you're having trouble with cold starts and the modifications that you've made, you would be changing the values in these tables. If you need to add a little bit more enrichment on super cold starts, you would do that here. The other thing related to fueling is your fuel enrichment under acceleration. So fuel enrichment increasing TPS. This is kind of gonna work like a carbureted car and an accelerator pump. Basically on tip-in, you need to add a little bit more fuel compensation because you can get lean conditions there. So this is gonna multiply your current fueling, and this is going to be fueling in addition to your base fuel table for acceleration. There is a decel version, so we'll go over that in the Burble tune section here, but this is where you would actually modify your fuel enrichment based on as you're decelerating. So now we're going to get into the ignition tables. So here we can see this is the ignition timing base map. And again, this is based on load and RPM. So here is where you're going to actually add power. In a lot of tuners, this is where the power is made in this table here. Usually you can add a couple degrees across the board with a stock map, depending on what kind of fuel you're running, and then kind of go from there. Here, the main thing is you really want to run on a dyno to get your ignition table dialed in, because you may not run into any knock when you add enough timing, but you may not make peak power at those numbers. So there is a decreasing benefit if you do add too much timing. Of course, if you switch from, let's say, 91 octane to race gas or E85, you can definitely bump those numbers up quite a bit. And that's where, obviously power is made based on your different fuel types. That's the reason, because those fuels are more knock resistant. Okay, so that's your main table there. And then we're going to get into, this is your idle base map. So when you're idling, it will actually use these values for timing advance. In this one, I believe is another idle map. This one here I wanted to show because I just want to show you from a base car perspective. When those intake temps get higher and higher, your car is going to pull quite a bit of timing, up to 1 degree of timing based on air temp and coolant temp. So remember when I was talking about logging those, and you're saying, why is my car not hitting these, requested timing values? Well, this table here, and actually there's another one too. So these two tables are the reason that it's going to pull timing if your motor gets too hot. And it's just obviously to protect your motor. You'll probably want to run more aggressive with these values here if you are forced induction, just to be on the safer side too. So now that we got some of the basics out of the way, I'm going to go over some of the more fun and cool stuff here. So the first thing is launch control. I kind of figured this out after reading through some of the forums. There's a couple changes you can make to have a launch control feature. So essentially, what it does is you're going to modify your engine speed limiter. Obviously, automatic or manual transmission, whatever you have. These tables here. You're going to modify this first cell, and you actually may want to change this to like maybe 5 kph. This is, obviously the metric version of miles per hour if you're not familiar with that. So basically your engine's going to have a RPM limit of whatever you set this to under a certain mile per hour. So as long as the car is not moving and you're trying to do a two-step kind of deal. So let's say I set this value to 3,000 RPM. So as long as you're going over this certain speed, this is going to be your rev limiter. The other cool thing you could do is while you're quote unquote two-stepping, you can probably shoot some flames if you modify these two values as well. So again, going back to your fuel injection base map, if you, whatever you set this value to, so if you come over here to 28 to 31, 100 RPM, if you add a bunch of fuel here, let's say like 10, 20% to this value, you can dump a whole bunch of fuel, and then in the same area, so in this ignition timing map, you modify the same area here. You can change this value to, let's say like negative 20 degrees of timing. And I think this is the max you can go on negative timing. But if you do these two, dump a whole bunch of fuel and retard the timing this much, you're definitely going to shoot flames out of your exhaust. So that's one cool feature. So this little setup here, you can do some two-step action. And if you have an actual turbo car, this will help and aid spooling a turbo, so it's not always just for show. If you're NA, this really won't have much of a benefit. All right, so now we're going to go over probably the most requested feature here, and that's the burbles, pops, bangs, popcorn, whatever you want to call it. So these are all of the tables you're going to have to modify. And I just have them all open so I can go through them all quickly. So we're going to start with the fuel restore RPM. This is going to change to these last two cells, whatever your rev limiter is. Let's say 7,000, and you can actually change your rev limiter to. I don't know why. Oh, here we go. So there you go. And then you can actually leave the AC on version stock or vice versa. So you can actually toggle the pops and burbles with the AC button. So that's kind of a cool feature to include. Okay, so in this table, we're going to change these two values, and we're going to change this one at a time. But these two cells are going to be minus 10 of what they are now. So there you go. There's your final values. I'm not sure. Some stock maps are different here, so you might want to start with your own settings and not physically copy mine. And then here, we're going to change this to -20. And it only goes to a certain amount set on the actual definition of this table. Okay, so moving on to ignition retard, decreasing TPS closed. You're going to change the last value to the max. That will go as well. So -20. And then ignition retard, decreasing TPS step size. This one, I have this set to 15 across the board here. And then, let's see, these two are going to be 15. So it's going to be 18. And this last cell is 51. Don't ask me what the step size does because I have no clue. I copied this particular part from guys that were messing with the pops and burbles to get good results. So this is what most people use. Okay, ignition retard, decreasing TPS step size, ECT compensation. This last value we're going to change to 6. And then ignition retard, fast decreasing TPS. So if you're just slamming shut the throttle, these are going to be the values there. So this last cell is actually going to be -40. Okay, and then for your fuel, you're obviously going to have to add a little bit more fuel when you're decelerating in these areas. So I usually add 0.05 from about 31 RPM all the way up to red line in this first load cell here. So again, 0.05 you're going to add to your stock values just to add a little bit more fuel. And depending on if you have cat still or catless, I mean, if you had too much fuel here, you could end up blowing your cats out. And if you want the Burble to be more aggressive or less aggressive and shoot flames, this is your main area where you're going to be adding or reducing fuel. So keep that in mind. And then likewise, in this table, this is your ignition timing. So similar to the changes that we made for the launch control, you would basically max this out to -20 degrees of timing all the way across the board. And again, if you want less of an aggressive burble here, you would be changing these values to, like, let's say -10 for a mild burble. So here's all the values. You can actually go on the ROM Raider forums, and there's a whole thread about pops and burbles and what other people are doing, and they post screenshots of all their tables too. So if you want to mess around with different settings, you can do that. So this next section is for turning on and off emissions devices. I hold no liability for any changes you make for these or legal binding changes. So you're on your own with this one. So let me go in here and just show you what I did. So these are all on and off values, true, false. So secondary air pump, if you want to delete that, you're going to be changing these two tables: secondary air injection system relay, secondary air injection solenoid. And then If you want to turn off your rear O2 sensors, so post-cat, the emissions ones, if you want to run aftermarket headers and still pass emissions, we're going to be changing the downstream O2 sensor heater, bank 1, sensor 2, and then sensor voltage. And again, these are just enabled and disabled, so you just disable those. Let's go back here. And then your cat converter overall efficiency. So if your cats become deteriorated, there is a check in the stock ECU. So you actually want to max this out to 255. And then going down here, let's see if I have any others turned off. You can change your vehicle speed limiter. That's pretty obvious. Your rev limiter, I wouldn't go too crazy with that unless you really know what you're doing. And again, all these engine speed limiters you can change to max those out. Now, the other thing that's kind of cool is you can tell the ECU to ignore a lot of these check engine light scenarios. So if you have something deleted or, like a charcoal canister that you don't really care about and you don't want to throw code, what you can actually do is go down to the very bottom in all these tables here and actually modify all of those. So here I have like charcoal canister, charcoal filter, running lossless valve, no clue what that is, exhaust flap, US E36s don't even have these. Evap system stuff you can change to ignore, so that's pretty useful. My car never has any check engine lights because a lot of this emissions crap is turned off and I won't even know if it was broken, which is kind of ignorance is bliss. So I hope you guys like this video. I put a lot of work into this. That's why part 2 took so long to come out, as I had to do a ton of research and make sure you guys had the correct information before diving into this on your own. It can be a little daunting at first, but again, those ROM Raider forums are pretty helpful. And again, that MS41 tuning Google site that I had posted in the first video, and there should be a link to that, is extremely helpful as well. So for some of those more advanced features, I may do a part 3 that has to do with force induction tuning, but I don't have any cars that are FI right now, so I may get into that in MAF scaling and tuning. So for some of the more advanced tuners that come from other platforms and getting into the E36 platform, they can get some knowledge from that. But I think that's it, guys. If you guys have any questions, let me know in the comments. And of course, subscribing helps out a ton. I really am trying to grow this channel and make it into something that is enjoyable and extremely helpful for people. So stay tuned for new content, and I'll see you guys in the next one.